So in part one, what we have is we have a chamber that has two plates in it. Okay? One positive and one negative. Okay? Now, the truth of the matter is when we deal with voltages, we don't have to necessarily have a positive and negative. We just need a positive and something a little less positive. But for the purpose of this demonstration or this problem, we're going to treat it as positive and negative. Okay? And in there, I inject vaporized matter. Think of it this way. So as an example, let's treat it as carbon. Okay, now carbon has several isotopes. One that we commonly look at is carbon-14. So imagine that you have a block of carbon, maybe a piece of charcoal. You vaporize that charcoal. You heat it up so it just simply vaporizes it. You don't introduce oxygen into the system, so it's nothing more than just pure carbon that's being vaporized. Okay? In the process of vaporization, that carbon atom has given up all of its electrons. Its electrons are just simply free to move about, so they do. They leave. They get out of the system. So now you have carbon floating around in between these two plates. Now imagine that this one's a carbon-12, and we'll use a different color to represent a carbon-14. Okay? So I've got two different particles. Now the carbon-12 and carbon-14 are, the 14 is an isotope, and all that means is that it has extra neutrons. And neutrons being charged neutral don't really play into effect when it comes to the amount of energy the object has. What it does do is it comes into effect about the amount of velocity that the object has. And we'll see it later on. And like I said, we'll see it later on. Okay? So when these particles are vaporized, they're exposed to this voltage. And instantaneously, well, no, let's not say instantaneously. They experience this pressure from this plate to move to this plate. Okay? And this plate's attracting it. Now, the amount of energy each one of those objects has is identical. If you think about it, the energy that each one of them has is equal to the amount of charge they have times the voltage in between the plates. Now, that's the maximum amount of energy they have. If you think about it this way, if I have particles that are vaporized and pushed into the system, some of those particles will end up here, and some of those particles will end up here. Well, the particles that end up here are going to be able to be pushed for further. The particles that end up over here are going to have less of a push. Now, there are ways in which I can make a constant voltage to the entire system, but that's really not what we're going to try to do. What we're trying to do is we're going to try to create the maximum possible. So what ends up happening is particles will enter the system, and we'll be able to dial in what particles we want. Okay? Now, both of these particles have the exact same amount of energy. Now, remember, this is voltage, and it's not velocity. Now, it turns into storage energy. It turns into this electrical energy, to kinetic energy. So there's work being done there, transforming it from one type of energy to the other. So as this particle moves from here to here, this energy is getting transformed into kinetic energy. Now you can see where the difference is right now. Okay? Each one of these two particles has the exact same amount of energy, but they don't have the exact same velocity because the mass values are different. Now, I take it to an extreme. Take it to a chemistry point of view. The mass of this one would be 12 atomic units, and the mass of this one would be 14 atomic units. That has an effect on the velocity that comes out of there. And that's really important because once we have that velocity coming out of there, we can throw it through our velocity selector, and we can eliminate the carbon-14 from the data. We can eliminate the carbon-12 from the data. Okay? And only be stuck counting the amount of carbon-12 that travels through. Now, mind you, think of it this way, too. If I had a carbon, I don't even know if one exists, a carbon-10, which means it only has, Well, he has 4 neutrons, which, like I said, I don't think exists. That'd be a very incredibly unstable. That particle would even have more velocity than carbon-12. Now, that does happen in other elements. I mean, there's not only just carbon-12 and carbon-14 when you talk about 14 being an isotope. Think about if there was a carbon-16 or a carbon-20 that are floating around in the system. I could dial in each one of those possible values by setting the dial over here on the second part. Okay? But the important part is that each one of those objects has the exact same amount of energy, but don't have the exact same amount of velocity. Okay? Cool? All right, let's move on to part 2.